All right, day 4, half a square. What does that mean? You will find out here in a minute. This is a good lesson, okay? We're going to start with a review of the Pythagorean theorem, and I kind of want you to just do this on your own, but in order to talk about it, I need to know the answers. So let's do this really fast. 16 plus 49 equals x squared. What is 16 plus 49? It's 65. And can we break up 65? I don't think we can. Factors of 65, no. We cannot break up 65. So x just equals the square root of 65. If we do the same thing over here, we get 8 squared plus 14 squared equals y squared. 8 squared is 64. 14 squared is 196. Again, you guys should be able to do this without me doing it for you, although I'm sure you're just copying this down. What is 64 plus 196? It is 260, okay? Now, the interesting thing about 260 is that 260 is divisible by 4. So that means we can break it up because 4 is a perfect square. And believe it or not, it's 4 times 65. Okay? So the square root of 4 is 2, and so we have 2 radical 65 equals y. Now, what do we notice here? Well, we notice that for x, we got the square root of 65. For y, we got 2 square root of 65. So y is twice as big as x, and that should make sense because this rectangle over here, KJLM, is twice as big as this rectangle over here, ABCD, okay? 4 times 2 is 8. 7 times 2 is 14. That means x times 2 equals y, right? So we're still kind of connecting this with what we did yesterday with these ratios and triangles and with similarity, okay? So because this angle is the same, these angles are the same, that means K has to be the same as B up here. That means the triangles are similar, and so all of our proportions should hold, all right? And so we're going to look at a specific case where we are going to make a 1 inch by 1 inch square. That's not a square. Let's try again. Okay. So this is 1 inch, this is 1 inch, and we want to draw a diagonal across the square. And we want to figure out what is the length of the diagonal. Now, we know that squares have right angles, so this triangle that we just made right here, okay, is a right triangle. And first they want you to do a prediction, all right? How big do you think it is? So do that on your own. And then they want you to calculate it. So we can calculate it with the Pythagorean theorem. 1 squared plus 1 squared equals x squared. Well, 1 squared is just 1, so we have 1 plus 1 equals x squared. 1 plus 1 is 2 equals x squared. Take the square root of both sides, and we get x equals the square root of 2. All right, so that is the length. You probably didn't guess that because it's not a whole number. It's a weird decimal, right? So what is the length as a radical? It's square root of 2. What is the length as a decimal? I should know the square root of 2 off the top of my head. It's 1.41 inches. Okay? So it's not quite 1.5, it's not quite 2, it's this weird decimal, right? So this length right here is the square root of 2. Now, what are these other angles? Let's see, do I talk about that? Yeah. What are these other angles up here? Well, we're cutting 90 degrees in half, so these angles are both 45, right? And so keep that in mind as we go down here. We want to draw a 2 inch by 2 inch square, right? So if we do that, again, we have 4 right angles because it's a square. We want to draw a diagonal across. we know that this is 2 inches and this is 2 inches, and we want to find out what is the hypotenuse. Now here, make a guess, right? Make a prediction, and then we're going to calculate it. Now, just like above, this is 45 degrees, and this is 45 degrees. So we have a similar triangle to our first triangle that we just looked at. So let's see what the hypotenuse is. We've got 2 squared plus 2 squared equals x squared. 2 squared is 4, and 4 plus 4 is 8. Now we can take the square root of both sides. We definitely can break up 8 into 4 times 2, and the square root of 4 is 2. So this is 2 radical 2 equals x. Which is twice as big as what we got over here. So over here, we got radical 2. Here we got 2 radical 2, right? Here the side length was 1. Here the side length was 2. So we made our square twice as big. That made the diagonal twice as big, right? So any square that you have is going to be similar to this square right here, which means it is proportional, right? So that means that here, right, so this triangle, this is half of a square, right? If we draw in the other half, right, we make a square where everything is 3 going all the way around. So if you have a triangle and its angles are 45 degrees, and 90 degrees, that is half of a square. So this diagonal here, the hypotenuse, that is the diagonal of the square, right? And so we know that this square is similar to our original square, our base square, right? So make a prediction for the length of this triangle, calculate the hypotenuse, so do the Pythagorean theorem. And it gets to the point where how can you figure out the length of a diagonal without having to do any math, right? So we don't want to keep doing the Pythagorean theorem over and over again. We want to try and find a pattern, right? Because if you can find a pattern, then that makes things quicker and easier for you. So here, we have 7 and 7, right? The pattern that you should get is that whatever the side length of the square is, it's that number times the square root of 2, okay? And this is really important for you guys to know, okay? When you have a right triangle and you have 45 degrees and 45 degrees, whatever your legs are, all right, the hypotenuse is that number times the square root of 2, okay? And so this gives us a nice little formula here for the side lengths of this special right triangle, okay? The other day, yesterday, we were looking at that, you know, that ramp where it was 4.8 degrees, and we knew that the side lengths had to be multiples of 1 and 12. Well, here, this is our pattern, right? So any right triangle has its own pattern, right? And this triangle that's half a square has this particular pattern. So you should be able to take any right triangle that has 45 degrees and 45 degrees. And if you know one of the sides, you should be able to get the other sides, okay? If this is 12, well, first of all, it's isosceles because those are the same. So that means this has to be 12. That means the hypotenuse has to be 12 radical 2, right? If you know the hypotenuse is, 23 radical 2, then you should be able to get the legs. You should be able to work backwards. They're both 23, right? And so if you know this pattern, you don't have to do any math. You don't have to do the Pythagorean theorem. You can just fill in the sides. So you guys have 8 problems that I want you to work on. You can submit it when you're done, and have a great day.